All right, so we're going to look into section 10.7, and this is trig, equations, and inequalities. It's just what it sounds like, equations and inequalities dealing with trig functions. We've got quite a list of suggested exercises here. We've got 3, 5, 9, 21, 23, 27, 47, 59, 71, 73, and 81. And I'm going to ask that you work through examples 1 through 3 in the book. So there's some different things we can do with equations and inequalities, but basically the way it's going to work is like this. Say solve for t. We've got sine of t equals 1, something like this. So solution, what we're going to do is we're just going to look at our unit circle here, and we're going to try to figure out which values on the unit circle give me a sine of 1. So sine is the y value. So which points on the unit circle have a y value of 1? Well, it's the top one. And we think of that as pi over 2, right? The angle pi over 2. It's, we're here and we go, right? So that gives us an angle of pi over 2. But what if we went up here and then went around again? Well, that would be pi over 2 plus 2 pi. Or what if we went around again and again and again and again and again and again and then ended up here? Well, that's pi over 2 plus several times 2 pi. Or what if we went around backwards a bunch of times and then stopped right here? Well, the way to express this is we say pi over 2 plus 2 pi n for any integer n. So that's our answer. T equals pi over 2. So that's our sort of our main part of our angle, and then plus any number of times around the circle, plus 2 pi n for any integer n. Remember, an integer is a number like 1, 2, 3, 4, 5, or 0, or the negative 1, 2, 3, 4, 5s, right? So it's not like, this doesn't just mean any possible number. It's not pi over 2 plus 2 pi times like 0.71 or something like that. So n has to be an integer. All right, so that's one kind of problem. Another kind of problem we could have, solve for w. And oftentimes we do omega, but in this case, in the notes I have w. Cosine 2w equals 1/2. Okay, so we're going to do cosine 2w equals 1/2, but because I don't want to have this for any integer n thing, I'm going to give us a restricted domain for w in the range 0 to 2 pi. I'm going to cut off the 2 pi there. All right, so solution, it's going to be kind of like the last one, but now what we're going to do, we're going to start by setting a new variable, theta, equal to 2 times w. And then, because I've got this 2w here, and that's just sort of different. And then I'll solve the associated equation for theta. So if theta is equal to 2w, that means that w, well, if w is in the range from 0 to 2 pi, that means that theta is going to be in the range, well, 2 times 0 is 0. 2 times 2 pi is 4 pi. Okay? And now let's solve. Cosine, well, our 2w is now theta equals 1/2. And so we can go over here and draw another unit circle. That is not a good unit circle. Oh, this is just a terrible unit circle. I don't know why I'm doing such a bad job with unit circles. Okay, well, whatever. Our x value is 1/2, and so what are the associated angles? Well, we've got right here, we got pi over 3, and then we've got this other one over here, 5 pi over 3, or you might think of it as negative pi over 3, either way. So cosine of pi over 3, as we recall, is going to be 1/2, and cosine of 5 pi over 3 is going to be 1/2, because it's symmetric, right? So this means that our theta is going to be either pi over 3 or 5 pi over 3. Now, but theta is anything in 0 to 4 pi. So we could also have these plus 2 pi. So it's pi over 3 or 5 pi over 3, or pi over 3 plus 2 pi, or 5 pi over 3 plus 2 pi. Now we don't need to go further than that, because if I add another 2 pi, then I'll be bigger than this 4 pi here. So that's my, that's not my final answer. So that's my final answer for theta, but now I need to translate things back into w. So since I had theta equals 2w, that translates to a solution for w, which is w equals theta over 2. Which means w equals either this over 2, that's pi over 6, or this over 2, 5 pi over 6, or this over 2, pi over 6 plus pi, or you can write 7 pi over 6, either way. And finally, the last possibility is this over 2, which is 5 pi over 3, 5 pi over 6 plus pi. Okay. And again, you could write that as 11 pi over 6, that's fine. So that's going to be our final answer there. Now, those are two different types of equations. To do inequalities, it's the same thing as doing equations, except we're gonna solve the associated equation to find the endpoints where the inequality changes from being true to false, and then just pick up the region in between. So here's an example. Let's solve for x in the region, in the range 0 to 2 pi. Sine x is greater than 1/2. Okay, solution. We just find the boundaries of truth. That is, where sine of x equals 1/2 for x in 0 to 2 pi. Okay, so where's that? Again, we go to a unit circle. We just draw a little unit circle here. Where does sine of x equal 1/2? Well, here's 1/2. That's either going to be, so this is the y value. This is either going to be pi over 6 or over here at 5 pi over 6, right? Those are the times when the y value is 1/2. And so, so this is going to be when x equals pi over 6 or 5 pi over 6. So where does this become true? So that was sine of x equals 1/2, but where does this become true? Where do we have sine of x is greater than, strictly greater than 1/2? So we need the y value to be above, and if the y value is above, that's on this circular arc here, which means any of these angles in between pi over 6 and 5 pi over 6. So our final answer is anything between pi over 6 and 5 pi over 6. So pi over 6 is less than x is less than 5 pi over 6. Or, so this is a perfectly fine answer, or we could write just like this, pi over 6, 5 pi over 6 in interval notation. Open interval because we need strict inequality. All right, hope that made some sense. Best of luck.